Hi everyone, this is the sixth video. We discuss about the vectors, and next topic is scalar or dot product. This topic also very important. Okay, scalar or dot product means what? See, if you take it as a two vectors, a bar and b bar vector, if you want to use the dot product, what happen? For example, a bar vector is there and b bar vector with some making an angle theta. What happened? This is the resolution of the vector. Yes or no? Already we discussed the resolution of the vector 2 dimensions and 3 dimensions in the previous video. Just look at the videos and after that you can listen this video. That is the b bar along the a bar. Means along the adjacent component. That is we got a b cos theta. Adjacent component will be gives the that's why AB cos theta, B cos theta along the A vector, B cos theta along the A vector. That is called as A bar dot B bar is equal to AB cos theta. Or otherwise, we can say that, for example, same vector will be there and B bar vector. And the A bar vector is I can draw the one perpendicular line. This is A bar along the B bar vector. A bar along the B bar vector. What happened? A cos theta. Same adjacent component. That's A bar along the B bar. That's a AB cos theta. BA cos theta or AB cos theta. Those are it same. From this concept, we can learn the some properties are there. We'll discuss now. Okay, A bar dot B bar is equal to what? AB cos theta. The first property, commutative commutative law. Commutative law. What is the commutative law? A bar dot B bar is equal to B bar dot A bar. Yes, already now we are discussed. A bar dot A bar dot B bar is equal to AB cos theta. B bar dot A bar is equal to BA cos theta. Those are in same. AB cos theta, BA cos theta. Those are in same. That's why it can be obeys the commutative law. And next one, distributive law. Next one, distributive law. Okay, what is the distributive law? For example, A bar, something you can takes the other another constant. For example, K bar dot A bar plus B bar. What need to write? K bar dot A bar plus K bar dot B bar. If that gives the values also, same will be getting. It obeys the distributive law. Already laws of vector addition, distributive law we discussed. We got the same. It obeys the laws of vector addition and subtraction. This is also distributive law always obeys the product of dot product or scalar product. Next one, if the angle between them 0 less than theta less than 90 degrees. What is that meaning? It's only first quadrant. See, we know the four quadrants, all silver teacups. All silver teacups. What happened? All silver teacups, all are positive. Yes, that is the 0 to 90 means 0 to 90 up to here. 0 to 90. These quadrant all are positive. Yes or no? Because of 90. That's why AB cos theta. Cos theta means cos is also positive. That is the AB is equal to, we got the positive value. Okay. Next one, 90 less than theta less than 180 degrees. What is the quadrant? Second quadrant from 90 to 180. Second quadrant which is positive, sign is positive. But remaining all components are negative. That's why we got the A bar dot B bar AB cos theta, cos component. The only sign is positive. Here only cos. That is why we got the AB getting the negative value. AB getting the negative value. And another properties we'll discuss. The continuation of the properties. The next one is, if the theta can be varies in a different angles, what type of product will be gives? See, theta is equal to 0 degrees. Theta is equal to 0 degrees. Then what happened? A bar dot b bar is equal to ab cos theta. Cos theta. Cos theta means what we apply here? Cos 0. What is the cos 0 value? 1. That is the AB we got here. Okay. Because of cos theta. Theta 0. Theta 0 means first quadrant. Yes or no? 0 to 90 is the first quadrant. That is always getting the, we discuss now. 0 less than theta less than 90 gives the positive. That is we got the positive value. If you taken as a theta is equal to 90 degrees, theta is equal to 90 degrees, then what happened? A bar dot b bar is equal to ab cos 90, cos 90. Then what happened? Cos 90 value 0. A bar dot b bar is 0 is equal to 0. This vector is called as a orthogonal vector. We call it as a orthogonal vector. A bar dot b bar is equal to 0. This vector we call it as a orthogonal vectors. When the a bar is one direction, yes, and b bar is the 90 degrees which is placed here, that is called as those vectors we call it as a orthogonal vectors. Okay, next one. If the theta is equal to 180 degrees, if the theta is equal to 180 degrees, then what happens? If the theta is equal to 180, the second quadrant will be gives a bar dot b bar is equal to ab cos 180. Cos 180 means it is the second quadrant. Only sign is positive. Remaining all are negative. That's a cos 180 value. How much it's getting? Minus 1. That is a minus ab. That's a negative. Yes. Already we discussed the 90 less than theta less than 180 gives the negative. That's a proof. Okay. Next one, if you want to take the a bar dot a bar, a bar dot a bar will be gives the a bar dot a bar means along the same direction. Yes or no? A bar is the same vector. This a bar also same vector. A bar is the same vector. A bar is the same. Yes or no? That's the angle between them 0 because of those are in parallel lines. That's what is the value? A square. Cos 0 value 1. Okay, this is called as a properties of scalar dot product. One more properties are there. We'll discuss now. That's a very important. Those properties. First, we want to draw the coordinate system: x-axis, y-axis, and z-axis. On x-axis shows the direction I cap. Yes or no? Already we discussed in the previous video. You can look at the video. After that, you can see this video. Without knowledge of this video, you can't understand. Okay, that's a k cap. Okay, those vectors, so those are in mutually perpendicular with each other. X-axis, y-axis is the perpendicular with each other. Y-axis and z-axis mean this direction. Yes or no? That's why on the board we can show like this. First of all, we want to write the I cap dot I cap. I cap dot I cap. What happened? I into cos. I cap dot I cap means same direction. Those are in I caps. That's a parallel. That is the 0 degrees. I into cos 0. Cos 0 value 1. I into I square. But unit vector whose magnitude is 1. That's a I cap is equal to 1. 1 into 1 square means what? 1. Yes? And second one, j cap dot j cap is equal to j cos. So along the y-axis, direction, that is the same. Those are in parallel line. That is the 0. What happens? J square. J square. J cap is the unit vector. That is always when you place the cap. That is always unit vector, which shows the whose magnitude is 1, and also shows the direction. That's a what happened 1. Next one, k cap dot k cap. K into cos 0 along the z-axis direction. That's a k square. K square means 1. K cap also unit vector. Whatever the vector is, the shows the cap. That's whose magnitude is 1. Okay, that is a k cap dot k cap gives the 1 only. Okay, next one we'll discuss the in other way manner. It's not a x-axis and y-axis we have to comparison. I cap dot j cap. I cap dot j cap. What is the I cap dot j cap? What is the angle between them? 90 degrees. That's a I into j into cos 90. Cos 90 degrees. Cos 90 value is 0. Yes, and I cap dot j cap is always 0. And next one, j cap dot k cap. J cap dot k cap, same. J k cos 90. Because of those are in mutually perpendicular. X-axis, y-axis is the 90 degrees. Y-axis and z-axis makes a 90 degrees. Z-axis and x-axis makes a 90 degrees. Those are in mutually perpendicular with each other. Cos 90 value is 0. And next one, k cap dot I cap. K cap dot I cap is equal to k into I into cos 90 value. Cos 90 value, what is the value? 0. Yes or no? In these cases, always in the reverse, x-axis, y-axis, y-axis, z-axis, z-axis and x-axis comparison, what is the value gives the your 0. But same axis gives the 1. Okay, once I will write here what we discuss in the this concept. First of all, we need to learn this one. I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. And other one, I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is equal to 0. In the other manner, yes sir. That's why we need to have to do the some examples also we'll discuss now. Okay, what are the examples? See, okay, just you can remember this one. Okay, we'll do the one example some you can understand. The first example is, for example, a vector is given. Okay, first of all, ax I cap plus ay j cap on y axis, az z axis k cap, and b vector bx I cap plus by j cap plus bz k cap. Okay, if you want to dot product a bar dot b bar, not addition, dot product we'll discuss. What is the value here? The first one. The first term will be multiplied with the other terms. Okay. Ax is multiplied with bx and by and bz. Next one, ay is multiplied with bx, by, bz. Az multiplied with, because of dot product, sn. Ax I cap into bx I cap. Bx I cap. Plus ax into ax I cap into by j cap plus ax I cap into bz k cap plus next ay multiplied with the b terms, ay j cap is multiplied with the bx I cap plus next one, ay j cap is multiplied with the by j cap plus ay j cap is multiplied with the bz k cap, and last one you can multiply with the more, az k cap is multiplied with the bx I cap, az is multiplied with the az k cap is multiplied with the by j cap, and last one, az k cap is multiplied with the bz k cap. Okay, from this equation, what is the final answer? See, already we discussed now. What is the I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. But I cap dot j cap dot k cap dot I cap is equal to 0. From this equation, see, I cap dot I cap, it's I cap dot I cap 1. Ax into bx. Ax into bx. See, I cap dot j cap. I cap dot j cap, what is the value? 0. X cap means I cap dot k cap. K cap dot I cap. I cap dot k cap. Those are in 0. Y and x. Y and x means uh, I cap dot j cap dot I cap is always 0. Next one, a y b y, j cap dot j cap is 1. That's plus a y b y plus y z means j cap dot k cap 0, k cap dot I cap 0, k cap dot j cap, k cap dot j cap means 0. What is the remaining? K cap dot k cap is equal to 1. That is the a z and b z. That is the a bar dot b bar. Okay, are you able to understand? Directly we can say how it is in a shortcut way. I cap dot I cap ax bx plus j cap dot j cap ay by 1, jz bz k cap dot k cap 1. That is always will be directly we can do this. Okay, you can understand this one. It is easy. And next one, what are the applications are there? What are the applications? Applications. So for example, work done we need to take first one. Work done. Work done means what? Work done is equal to force into displacement. Means F bar dot S bar. F bar dot S bar. What is the F bar dot S bar? Fs cos theta. Fs cos theta. This is the one of the application of the scalar or dot product. Dot remove. We can place the Fs cos theta. Okay. And the next one, second applications, angle between the two vectors. Angle between the two vectors in a dot product. Angle between the vectors. Okay, what is the angle between the vectors? See, a bar dot b bar is equal to ab cos theta. Ab cos theta. If you want to find the angle, ab cos theta we want to take. This term will becomes the right hand side. A bar dot AB. Okay, that's easy to find out here. Cos theta is equal to A bar dot by B bar dot. For example, if you want to write the A is equal to A1 I cap plus A2 J cap plus A3 K cap, B bar is equal to B1 I cap plus B2 J cap plus B3 K cap. Dot product means what we got? Already we discussed A bar dot B bar is equal to A1 B1 I1 I cap dot I cap 1. Remaining all are 0. J cap dot J cap 1. That's the A2 B2. A3 B3. Remaining all are zeros. Yes, these we got here. That's why we can apply here A1 B1 plus A2 B2 plus A3 B3. Okay. And next one AB. A means magnitude of A. B means magnitude of B. A means magnitude. How can you find out the magnitude? A is equal to square root of A1 square. I square means 1. A2 square. J square means 1. K square means 1. Because of unit vector. 1 square means 1. Yes. B also we can write B1 square plus B2 square plus B3 square. We can write here. A1 square plus A2 square plus A3 square into B1 square plus B2 square plus B3 square. That's how we can write the angle between the vectors. Next one. Component will be projectile in another way. Okay. If the which direction will be moving in the vectors. That's how we discuss. Next one. For example, if the cos component A bar dot B bar is equal to AB cos theta. Yes. From the cos theta, we'll give the A bar dot B bar by AB. If you want to find the A is along the B vector. A is along the B vector. That's why we need to write the unit vector also B cap. That's why we can write the B cap along the direction. B cap indicating the direction only. Okay, that's our value is 1. It doesn't changes the magnitude. Yes or no? If you want to place here B cap, doesn't changes. 1 into anything, anything will be gives. It's based on A cos theta, B cap is equal to A bar dot B bar by B. Means A vector along the direction of B vector. That's what we need to find here. Otherwise, if the same way A bar dot B bar, AB cos theta, the B bar along the A direction. That's a B cos theta is equal to A bar dot B bar by A. So along the A direction means A is the unit vector, that is the direction. Okay, that's indicating the in this way. How it is possible? We can find out that there are so many sums based on these formulas. Sometimes they given the two vectors which need to find the angle between the two vectors. That is called as a, this is the very important formula. This is called as a scalar or dot product. We'll discuss. Okay. In the next video, we'll discuss about the vector or and cross product, vector or cross product. If you like the video, subscribe and share it. Thank you.